This is your flipped lesson on the states of matter. This will be vocab entry number 3 in your vocabulary notebook, so we'll take notes accordingly. Don't forget, I'll tell you what vocabulary words I want you to have in there. I will tell you the definitions, and always, always, always include a picture. This time I will be checking for color, so make sure on Wednesday when we have our vocab notebook check that you have everything fulfilled that I've asked you to. I hear there might be a vocab flipped lesson quiz with this particular vocab entry, so be prepared. All right, let's get started. We're talking about states of matter. This is a concept that you should have seen in elementary school, so hopefully some of this will be old material that you've already seen, some of it might be new material. We have 3 states of matter. We have a solid, a liquid, and a gas. And we can turn each of these states of matter into the other by some very simple steps. And we're going to talk about those steps as we go. So let's tackle solids first. First of all, solids have a fixed volume and shape. It's not like they're oozing all over the place like water on a table or things like that. Definite volume, definite shape. Particles, or the molecules in a solid, are tightly packed together. Everything is nice and tightly packed together in a solid. If we're talking about ice, which is a great example, or we're talking about this table right here. All right, the molecules in both of those things are very tightly packed together. We can turn a solid into a liquid, and with a liquid, different characteristics. All right, first of all, liquids have a fixed volume. They take up a specific amount of space, but they take the shape of their container. So if you think about a cup of water, if you put it into a big tube, it will take the shape of the tube. If you put it into a shallow pan, it will take the shape of the shallow pan. Particles in a liquid are moving a little more freely, so they're not tightly packed together like a solid. They start to get a little more energy to them, and they get a little movement. All right, think of water. You can take a cup of water and tilt it back and forth, and you can see it move a little more freely than when you're holding an ice cube. An example here, liquid water. Our final state of matter are gases. Gases are very unique in the fact that they don't have a fixed volume or shape. They go all different directions, all right? They don't have a fixed volume or shape. Particles in this particular case are moving the most freely, all right? You think about the air. There are particles in the air right now moving with lots of energy. Very different than a solid. Solid, tightly packed together. In a liquid, they're moving a little bit more. In a solid, they are going all different directions. An example in this case would be steam. All right, so for this vocab entry, you will want to put the title of states of matter. You have 3 vocabulary words: solid, liquid, and gas, and information about each of those. For my pictures, what I would do, I would go ahead and draw an example. Draw an ice cube, draw a cup of water, draw steam coming off of a pot of boiling water. Our next part of this vocab entry, and the word is going to be solids to liquids. I know it's more than one word, but this is a process that you're going to have to know. If we want to take an ice cube and we want to turn it into liquid water, what do we do? First of all, that's called a melting point. When you take a solid and you turn it into a liquid, that's called the melting point. And we're going to use water as our example through all of this. Our example of water, the melting point of water is 32 degrees Fahrenheit. That's actually the freezing point of it, which is the opposite of melting point, and we'll talk about that. And 0 degrees Celsius. We'll most likely use our Fahrenheit temperature since most of you aren't familiar with Celsius temperatures. But I wanted to give you those pieces of information there. If we go above 32 degrees Fahrenheit, ice will begin to melt. Okay, that's why it's called the melting point. This is the threshold temperature of when ice goes from a liquid to a solid, and vice versa, a solid to a liquid. So imagine in our square here, we have this ice cube, and all the molecules are very tightly packed together like they are in all solids. If we add energy in the form of heat, and that's my best picture of a fire I could do. If we add energy in the form of heat, what starts to happen? If you take a look here, the particles or the molecules begin to spread apart as they heat up. This will form liquid water. Notice how the particles are more spread out in liquid water than they are in an ice cube. Okay, this is going from a solid to a liquid. If we take the temperature above 32 degrees in water, it will begin to melt. Molecules will start to move further and further apart. These make great pictures when you're doing your vocab entry for solids to liquids. What happens if we want to go from a liquid to a gas? Okay, another vocab word here, liquid to gas. This is called the boiling point. And you think about water on a stove, it boils at a certain temperature. That temperature is 212 degrees Fahrenheit or 100 degrees Celsius. So here was our liquid water, right? From our ice cube to our liquid water. We add energy or heat. That is going to make the particles move farther apart as more energy is added, and we get steam. Okay, in steam, these water molecules are so far apart and have lots of energy because they've had heat added to them. All right, so this is called the boiling point. If we're below 212 degrees, water will not boil, and it won't go any higher than 212 degrees. That is called the boiling point. Oh, I saved it. All right. If we want to go backwards, we went from solid to liquid, liquid to gas. What happens if we want to go backwards? Let's go from a gas to a liquid and then a liquid to a solid. We remove heat from the gas. All right, so we take away that heat, the particles, and that will say slow down to form a liquid. All right, so if we take gas and we remove the energy from it, take away the heat, the particles start to slow down a little bit, and that will form a liquid. If we remove even more heat from the liquid, the particles will slow down even more, forming a solid, and that is the freezing point. And for water, that is 32 degrees Celsius. Okay, the particles reach a point at 32 degrees Fahrenheit. When water reaches that point, the particles are no longer moving. They've reached that point of freezing, okay, tightly packed together. There are some substances out there that go through something called sublimation, and this is where they go from a solid straight to a gas. There is no liquid state. An example would be dry ice. All right, dry ice will sublimate. It won't go to a liquid state. It goes straight from a solid to a gas. It's important here, drive home point that I want to make sure you write down in your vocab notebook. All matter has a unique melting and boiling point. All right, not every piece of matter is going to boil at 212 degrees or freeze at 32 degrees. That's specific to water. So it's important to know that all matter has unique numbers when it comes to boiling points and freezing points. And this is our vocab entry for states of matter.